Hey everyone, today's lesson is lesson 21 and it's word problems about equal groups. And with this, of course, we're going to really be talking about dividing, and then with that, its inverse operation, which is multiplying. Ways to think about word problems and really everyday math, things that you're doing in your everyday life that involve this type of math, whether your brain thinks about it as dividing or multiplying. We're going to kind of talk through that a little bit. Moving forward, your learning targets for today are to translate and solve word problems about equal groups, whether that be multiplying or dividing, and then also deciding if the answer to a word problem about equal groups is reasonable. So, a little bit more about that. Today in math class, I brought in some cookies. So, when they're asking mathematicians to think about if their answer is reasonable, they're talking about this. Sometimes in math, when you're dividing problems out, they don't divide into equal groups perfectly. So, not even or equal groups, you end up with a remainder. Sometimes it's appropriate to leave a remainder, and sometimes it's not necessarily reasonable. So, up a little bit further, when they were talking about asking if your answer was reasonable, sometimes it's not. For example, I brought in this package of cookies today. Depending on how many students I had in the class, let's say, I don't know, I'm making up some numbers really quick. Let's say there were 22 people in the room and each pack of cookies only had 20 cookies in it. If that were the case, I couldn't just go to the store and buy one package of cookies plus two more cookies, especially right now with all the germs. You can't just buy two cookies. I would have to buy a second package of cookies. So in this case, if that was some type of math question I was asking you, it wouldn't make sense to say one remainder two, like one package with two remaining. We would just have to go and buy two packages of cookies. We'll talk more about that a little bit later as we dive into more complex division problems. But I just want to scroll down a little bit here and give you an example. Back to the cookies, just to give you an idea. On the back of the package of cookies, here's what it said. Let me scroll out maybe so you can see a fuller screen. So when you have word problems about equal groups, they're just basically saying you're taking the number of groups times the number in each group and it gives you a total. So for example, on the back of my package of cookies today, it said that there were 11 servings and each serving was 3 cookies. So really quickly, when I was standing in my pantry this morning, determining if I would have enough cookies for everyone in the grade, I just took 11 times 3 in my head, and I determined each package of cookies had 33 cookies. Not enough for the whole grade, but enough for one class. On this next one here, see, I left my writing from my math class this morning, and I was going to try to cover that up. So I don't know. Maybe I'll try to show the screen just from here, and then I'll scroll down. It's just such better handwriting than when I write on my touchscreen. So at Lincoln School, there were 4 classes of fifth graders with 30 students in each class. Altogether, how many students are in the 4 classes? So from home, go ahead and pause this video right here, give this a try, and then unpause when you're ready. I might even try to do that as well. I'm going to play around with pausing my video. Okay, so you can see here I've taken 30 students in each class times 4 classes, and we end up with 120 students. Just a quick mental way to think about this, 3 times 4 is 12, so 30 times 4 is 12 plus a 0 on the end. So we have 120 students. I'm going to scroll just far enough to see the problem again. Ooh, that's tight. I'm sorry. Okay, a coach separated 48 players into 6 teams with the same number of players on each team. How many players were on each team? Okay, so go ahead and pause right here and give this a try. I want you to see the 2 different ways of thinking about this problem. Both are correct. It's just how your brain thinks about math. And really good mathematicians, if they think about one way, then they challenge themselves to think about the other way too. More ways to solve, the better. So the first way you can see I've demonstrated how to solve with dividing. So I've taken the 48 players Separated, that's why I've boxed this word separated. It's one of those math vocabulary terms that when you hear that, your brain should signal that you're going to be dividing. You're separating out. Just like I took my package of cookies this morning and I separated them out onto the desks. I divided them out amongst students. So a coach separated these 48 players into 6 teams. So I've separated into 6, and then of course 48 divided by 6 gave me 8. I don't have my label up here on the screen, but really important to label here how many players on each team. Our label is players, 8 players. Down here a little bit further, I've just demonstrated how to think about this with a multiplication mindset. Oftentimes I find that students find thinking about things in a multiplication mindset is easier than dividing. I don't know, whatever works for you. If you think about it like that, here's what you're thinking. 6 equal teams times how many people, this was blank, how many people on each team is going to give me my 48 total players. And again, 6 times something equals 48, and I get the 8 players on each team. There we go. One last one to try. I'm going to read it, and I wish I could move this little box here, sorry. And then pause it, give this a try, and then you can see my work. Monifa raked leaves and filled 28 bags of leaves. On each trip, she could carry 4 bags with leaves. How many trips did it take her to carry all of the bags? Go ahead and pause, give this a try, whether you use multiplication or division, and then check your work with mine. Okay, so again, you can see I've demonstrated using both forms of math, or both operations, I should say. We have the 28 total bags divided by 4 bags per trip. I know that she can carry or get rid of 4 bags on each trip that she takes. And when I did that math, 28 divided by 4, I ended up with 7 trips. It'll take her 7 trips. Moving on to the inverse operation, which is multiplying. Multiplying is the opposite or inverse of dividing. We can think about it like this. She can take 4 bags on each trip. 4 bags times how many trips is going to get rid of my 28 bags. So I'm just saying 4 times what is going to equal my 28 bags. And of course, again, I get 7. 7 trips would be my label. That's it for your practice today. Just remembering that when you're looking at these word problems, if you solve by division, it's right. If you solve by multiplication, it's right. If you're ever wondering and want to double check your answer, try the inverse operation and see if you get the same answer twice. Thanks so much for watching and have a great day.